Get ready to blast off into the future of space exploration. Today, we are diving into a mind-blowing AI breakthrough that could accelerate our journey to colonizing the Moon and Mars. You might be wondering, how is this even possible? Well, buckle up, because we are about to explore some cutting-edge technologies that will make you rethink the limits of human ingenuity. Imagine a space mission where a single hardware failure could spell disaster. In the vastness of space, sending a repair team or spare parts is a distant dream. This is where predictive maintenance steps in as the hero of our story. It's like having a crystal ball that can foresee equipment failures before they happen. This revolutionary approach combines three powerful AI techniques. First, anomaly detection acts as the vigilant guardian, constantly monitoring systems to catch any operational hiccups. Then, time series forecasting predicts the lifespan of hardware, ensuring we are not caught off guard by mechanical wear and tear. But wait, there's more. Digital twins create virtual clones of our spacecraft, allowing us to stress test them in extreme scenarios, all from the comfort of our mission control. Now, let's talk about the economics of space travel. Sending cargo into space is ridiculously expensive, especially when it comes to Mars. We are talking tens of thousands of dollars per kilogram. This is where In-Situ resource utilization comes to the rescue. Instead of relying on costly resupply missions, we can become space miners, extracting resources like water, ice, and minerals from the very planets we aim to inhabit. AI algorithms can scout these resources, ensuring we know exactly where to find them. And get this, AI-guided robots can then extract and process these resources autonomously, even in brutal conditions like -202 degrees Fahrenheit on Mars. It's like having a team of robotic miners working tirelessly to support our settlements. But the AI magic doesn't stop there. On Mars, with its CO2-rich atmosphere, AI-monitored reactors can turn atmospheric gases into rocket fuel. Talk about a sustainable fuel station in space. On the Moon, AI optimizes oxygen extraction from lunar regolith, adapting to the ever-changing raw material composition. These processes are like a space-age alchemist's dream come true. As we venture further into space, we encounter new challenges. Orbital debris and potential collisions pose serious threats to our satellite networks, which are the backbone of our modern world. Here's where AI tracking systems shine, acting as vigilant space traffic controllers, keeping our satellites safe. And when it comes to long-duration space missions, medical care becomes a critical concern. AI-powered diagnostic systems can monitor astronauts' health, detect issues before they become critical, and even provide mental health support. It's like having a personal doctor and therapist on board. However, with great power comes great responsibility. As we hand over control to autonomous systems, ethical questions arise. What happens when these systems make critical decisions about life support or emergency responses? Who's accountable if something goes wrong? These are the deeper questions we must grapple with as we embrace AI-driven space exploration. In my opinion, this AI breakthrough is a game changer. It's not just about the technology. It's about pushing the boundaries of what we thought was possible. It challenges us to rethink our approach to space exploration, making it more sustainable and efficient. Personally, I find it fascinating how AI is becoming an indispensable partner in our cosmic endeavors. It raises the question, what other incredible innovations are on the horizon? The future of space exploration is not just about reaching new frontiers, but also about the incredible tools we'll use to get there.